Hello friends, welcome to my YouTube channel. So we're looking at this question. It says that the uncertainty in the momentum of a ball is traveling at 39 meters per second is 1.0 times 10 to the power negative 7 of its momentum. Then the question is trying to say, what is its uncertainty in position, whereby we're given that the mass is equal to 0.40 kgs. So we have to find the uncertainty in position. So to do this, we're going to use a principle known as the Heisenberg's uncertainty principle to simply solve for the uncertainty in position. Okay, now the Heisenberg's uncertainty principle simply states that the product of the uncertainty in position and the uncertainty in the momentum is either equal or greater than the Planck's constant over 4 pi. So it's either greater or equal to the Planck's constant over 4 pi. Okay, now let us simply first find the uncertainty in the momentum. Then from there we can see how we'll go to simply solve for the uncertainty position. So the uncertainty in momentum is equal to the value that we've been given, which is 1.00 times 10 to the power negative 7, to multiply with the momentum of the same object. Now momentum is simply given as the product of the mass and the velocity. Now here, to find the momentum, we'll just say that momentum will be equal to the mass is 0.40 as we are given in the question, then times the speed, which is 39 meters per second. Now upon solving, we get that the momentum is equal to 15.6 kg meter per second. Okay, now since we found the momentum, let us substitute in the uncertainty for momentum, then we solve. So the uncertainty momentum will be equal to that value we have, which is 1.0 times 10 to the power negative 7 multiplied by the same value for the momentum, which is 15.6. Now upon multiplying the two, we simply get that the uncertainty in momentum is nothing but 1.56 times 10 to the power negative 6. The units are kgs meters per second. Okay, so now we found the uncertainty in momentum. Let us now go back to our equation and solve for the uncertainty in position. So I've write our equation again. Uncertainty in position times uncertainty in momentum less or equal to greater over this that is on the right hand side. Now we're going to make the uncertainty in position subject to the formula, so divide by the uncertainty in momentum both sides. So upon doing that, we're going to have the uncertainty in position to be either greater or equal to h over 4 pi, then uncertainty in momentum. So let us substitute. So the uncertainty in position in this case will simply be greater or equal to the Planck's constant is given as 6.6. So sorry, that is supposed to be 6. So let us erase this one. So we have 6.626 times 10 to the power negative 34 joules seconds as the units for the Planck's constant, then over, so we say 4 pi, so 4 times 3.142 times the uncertainty in momentum, which is nothing but 1.56 times 10 to the power negative 6. So we're going to say that uncertainty in position would be greater or equal to, so we write the numerator the way it is for now, which is the Planck's constant. Then when we multiply on the denominator, we're going to get nothing but 1.96 times 10 to the power negative 5. So when we divide, we get that the uncertainty in position will be greater or equal to 3.38 times 10 to the power negative 29 meters as the solution.